Okay, so now, these are hard for some people. We're going to talk about oblique projection or shortening and other methods of depicting three-dimensional space on a two-dimensional surface. So earlier in the chapter, we talked about 1 and 2 point linear perspective. Not really earlier in the chapter for some of these. Some of these came before that, but we talked about it nevertheless. And I'm just going to remind you that in 1 point and 2 point linear perspective, the closer something is to us, the larger it appears. The further away something is from us, the smaller it appears. So when you're drawing along the diagonal lines that run along the objects, these lines are further apart here, and they get closer and closer together the further away they are in space, and therefore they make the object appear to be smaller the further away it is from us. But oblique projection is a little different than that. So we're going to start with oblique projection. So this is a way of creating a three-dimensional space that on a two-dimensional surface that does not use a vanishing point. So you can find this in historic Japanese artworks as well as other cultures, and you can also find it in video games such as The Sims. I don't know, do people still play that? So we're going to look at The Sims because I kind of love how silly they are, and if you don't pay attention to what's going on in your house, stove will catch on fire, like somebody will die, crap will fall on the floor. So anyway, this image is drawn in oblique projection, and it follows all the hallmarks that are used in oblique projection that you can use and recognize in it. So first of all, the image is viewed from a high vantage point. So we are like up in the air, floating over the Sims home in an airplane, or maybe it was photographed by a drone. So you're like way up high and you're looking down below on a scene. So that's one of the hallmarks. So let me just go back. Like, see, we're way up high and we're looking at these two. So then the second hallmark is there's no vanishing point. So all lines that run along the width of something remain parallel. They don't get closer together, they don't converge, and all lines that run along the length of something don't get closer together, they remain parallel. So we're looking at this along the width. So the width of this table, if we draw along the edge and extend it out on either side, it remains like pretty much the same distance apart. Same thing with this counter in the kitchen. We run along the width of it, and those lines are parallel, and they do not converge upon one another. They do not get closer together, and objects do not appear to look smaller the further away they are in space. Then we go along the length of the object, same thing. We run along the length of the table. I'm not making up where the lines are. I'm drawing over these existing edges and I'm extending them out just to illustrate my point that these lines remain parallel. Same thing with this little island or whatever this is over here, little kitchen cabinet. The lines remain parallel. We can find other examples in this image, but for the sake of brevity, I'm not going to bore you, hopefully. So then when we're looking at some Japanese works of art, we can also tell that it possesses those hallmarks of oblique projection. We're looking at the scene from up above. So we're like higher up, we're like on a mountain or something. Then we look at these. These are lines that are running along the length of this bridge or walkway. And these red lines that run along the length, they remain parallel. They don't get closer together the further away we are. And there's the same amount of space between those parallel lines. We look at the lines. These are little segments of this walkway. We draw lines on those. Those lines that run along the width of that object remain parallel, don't get closer together, don't converge upon one another, and there's no vanishing point. So that's oblique projection. We also talked about axonometric projection, perspective that architects use. It's really similar to this. High vantage point, things are presented as an angle, parallel lines remain parallel. The only difference between axonometric projection and this is that the architect is very precisely measuring all those lines because they want to present it to a contractor so that they can make the building accurately. So then the next thing we're going to talk about is stacking. Stacking is used in some Native American cultures, some African Neolithic cave paintings, in some contemporary and historic African art, such as the barber shop signs of Ghana. So again, in stacking, there's no vanishing point. In stacking, objects do not typically touch one another or overlap. Occasionally they will, but usually they don't overlap one another. And so there's spaces between objects. And then the other thing is that objects placed down lower in the image are considered to be closer to us. And then the higher up in the image, they're considered to be further away. So this guy here on the horse, these guys, they're closer to us. These guys, I think this must be like Custer's Last Stand. Those guys are in the middle ground. And then these people back here and their horses are in the background. So here's another example. So on the left is a barbershop sign from Ghana. I love these barbershop signs from Ghana. They're some of my favorite works of art. Look, this looks like Eddie Murphy down here. So these guys, they're not overlapping one another. And the ones at the bottom are considered to be closer to us. And the further back they are, the further away. There's no vanishing point. And this is example of stacking. And then when you look at some Neolithic rock arts, this is in the Sahara, or you look at like some cave paintings in other cultures, there's no overlapping of figures and objects. There's space in between the figures and objects. And so the ones down at the bottom, these men and this oxen, they're considered to be closer to us. And then the further back in the image we get, these guys, they're further away. Okay, so now foreshortening. And this is the one that sends people over the edge because for some reason it's hard to understand. So foreshortening is a way of representing a subject or an object so that it conveys the illusion of depth. And usually the object or the figure is positioned in such a way, not even usually, always. So part of the object appears to be closer to us in proximity and space, and part of it's much further away. Something else that happens when you foreshorten an object, it makes it look shorter than it would be if it were standing up because it compresses the space. That's kind of why they call it foreshorten, because it makes these objects appear three-dimensional, appear like they're projecting back in space. But if you measure, they're going to appear to be shorter than something that's standing upright. So let's compare two objects that are, one object's not foreshortened, the other is foreshortened. There's a guitar. And here is a foreshortened guitar. So with this guitar that's not foreshortened, like all parts of it that I see is in equal proximity to me. So if I'm standing down here and I'm like, I'm going to walk to that guitar. Boo, 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 boo. Oh, I reached it. Boo, 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 boo. Oh, I reached it. You're going to reach it all at the same time. Like no matter where you are down here, like as you move along, it's equally, every part of it's equally close to you or far away from you. So then with a foreshortened guitar, when you look at it, part of it's closer, part of it's further away. So the neck is jutting out, is closer to us in space. Then as we, or that's the head rather, then as we move along the neck of the guitar, it's like getting further and further away, and then the body is even further away. So just to reiterate, when objects are foreshortened, one end of the object seems to jut out and is closer toward us and it's closer to us. And the other end seems to jut away from us and is further away from us. So here's another example. So this is a detail from Raphael's School of Athens. And this is Plato on the left, and this is Aristotle. Plato has his arm up. His arm's not foreshortened, like his hand and his elbow are equally close to us. But then Aristotle, he's like demonstrating a point, and his arms outstretched. So his hand's closer in space to us than his elbow and his shoulder are. So his hand's pushed out closer to us. So his hand and his arm here, they've been foreshortened. And the length of his arm looks shorter. Like if he was to hold his arm down straight, well, this forearm would look a lot longer than it appears here. But because it's foreshortened, we don't get to see, we don't get to know the full length of it. So here's another foreshortened image by Charles White of a preacher, and both of his arms are foreshortened. So the palm of his hand is closer to us, and the rest of his arm is moving away. His extended finger is closer to us, and as we move along his arm, his shoulder's further away from us. So he's foreshortened. This horse by Degas, we're seeing the rump of the horse is closer to us. Head of the horse is it's far away. The horse is foreshortened. This horse, my friend, is not foreshortened because like all parts of it that we see are in equal proximity to us. Now, you don't have to see, like what if we just saw the head of the horse like this? Well, we'd still know it's not foreshortened because all parts of it that we see are in equal proximity to us. So that, my friend, is my little lecture on different ways of expressing three-dimensional space on a two-dimensional surface. Thank you.